So today we're going to be talking about how to resolve vectors into the vertical and horizontal components. So I've written down the formulas here for how to do it. So for horizontal, it is the force, magnitude of the vector times cos theta. Vertical is magnitude times the sine theta. So that might look like, in a real example, it'll look like this. So we have a vector, okay, like this. And let's say the magnitude of that vector is 15 newtons. All right, so we're dealing with a force vector as a magnitude of 15 newtons. And we need to also know the angle in order to resolve it into its horizontal and vertical components. So if we pretend that this is on a Cartesian plane, so I'm going to draw the y-axis and the x-axis this way. We have to know this angle here, all right? This one. That is the angle that we need in order to find the horizontal and vertical components. So for this example, let's say that angle is about 45 degrees. Okay, and now we can just put those numbers into our formula and we'll get two different components, horizontal and vertical components. All right, so if we put those calculations in, we get a different number for the vertical and horizontal components. So we can see that in the horizontal we get 10.6 and also vertical we get 10.6. But this is different to our overall force of 15 newtons. So the reason why that is different is because we have forces acting in both the vertical and horizontal directions. So there's going to be forces acting this way and this way. And because they're both the same for this example, that resultant vector is right in the middle there. That is just because this is 45 degrees. If this was 50 degrees, let's say it was 60 instead of 45. If it was 60 degrees, then that angle is going to change significantly, and there's going to be more force acting in the vertical direction. Okay, but for this example, it is the same. And if we talk about velocity vectors, so this is a force vector, but we can do the same for velocity as well. If we have a velocity vector going this way, let's say that that is 15 meters per second. Okay. And because that is acting in both the vertical and horizontal direction, we could split it up into its velocity in x and velocity in y as well. So if this angle was, say, 20 degrees, we could do exactly the same process like we did up here. We would just have to then resolve it into its vertical and horizontal components.